Let us first identify a simple program which is used as an illustration for these arrays. What are the fundamentals which you heard in the previous video? All those fundamentals are now going to be implemented in this particular program. We have studied these fundamentals as separate bits. Now let's merge all these fundamentals and put a program. What I mean by finding the sum of given n numbers. Let me explain the logical stuff and then we'll see how the coding is supposed to be done. Basically, the user is going to give you a set of numbers. But I'm not aware how many numbers the user is going to enter. For that, what I'll do is, I'll do two things as input. First, what I'll do is, I'll read the length. Let me say, I'll ask the user how many numbers he's going to enter. Is he going to enter 1 number? Is he going to enter 5 number? Is he going to enter 10 number? Is he going to enter 20 numbers? So I'll ask the length of the numbers. And then the second input which I'm going to go to is, I'm supposed to read numbers in this case. So first read the length of the array and then read the numbers. Now when I say length of the array, can I allocate the size as per the length? No, not possible. Irrespective of the length, I had to always declare array. So what I'll do is, I'll declare an array as a int a of 50. Believing that the user is going to have maximum set of numbers as 50. The user will not go beyond 50 numbers. So when I say int a of 50, this will have a storage space of 50 values, where the first index is a of 0 and the 50th index is a of 49. Now when I read the length, assume that the user is going to enter the length as a 7 numbers. Now when I say 7 numbers, what happens to this particular set of 7 numbers? The user will read 1, 2, 3, 4, 5, 6, 7 numbers. So we were saying that if I have 50 numbers, I have a of 0 till a of 49. Now if the user says the length is 7, in that case, I had to only allocate the first 7 locations, 1, 2, 3, 4, 5, 6, 7. 7 locations will be used. What happens to the remaining locations? Will they be used or will they be allocated to someone? They will neither be used by someone. They will not be allocated to anyone. These locations are going to be wasted. They are going to remain idle even though they are not used by the current program. Because arrays are said to be the best example of static memory location. Now with this notation, you can very easily understand what do you mean by static memory location. Now sir, I have a requirement of 7 numbers, but I have allocated a size of 50. It means that I can't compress this particular array. Later on, in the next execution, if I execute this particular program for one more time, if the length of the array is say 70 numbers, if they say that I have to do operation on 70 values, there is not an expansion possible. Arrays can neither be compressed nor be expanded, which means that this array is static in nature. Once declared with the size, it will be. Rather than declaring the array at the beginning, will you say that I'll declare it after reading the length? No, you can't do that. You can't do that because your array at any place of declaration, either at the beginning, in the mid or just before its use, needs always a constant number in the bracket as an index value. Since there will not be any concept of declaring an array dynamically as per the user requirement. But with the additional concepts of pointers, you can actually declare arrays which are dynamic in nature. That will be the latest stuff. Right now, come back to this particular example. We have said that I'm supposed to find sum of given n numbers. If the user says 7 values, I'll ask the read the numbers. I'll ask the user to enter the numbers. User enters the numbers as say 12, 1, 5, 7, 2, 9. The user has entered say 8. The user has entered these values. The user enters a of 0 as 12, a of 1 as 1, a of 2 as 5, a of 3 as 7, a of 4 as 2, a of 5 as 9 and a of 6 as 8. Now these values have been read and these values need to be added. I want to find the sum of all these given n numbers. So total numbers for 7, I am supposed to add these values. So what I'll do? For that, I'll use a simple logic. I'll take variable s, set this with 0 initially. 0 is added with 12 and the result is stored back to s. 12 is added with 1, 1 plus 12 is 13. 13 is added with 5, that becomes 18. 18 is added with 7, then the result is 25. 25 is added with 2, the result is 27. 27 is added with 9, the result is 36. 36 is added with 8, the result is 44. If I have these n numbers, I just kept on adding the value of s. S was what initially? 0. S was added with every element of the array and the result is stored back to s itself. One arrow goes up and one arrow comes down. So here 0 goes up, 12 comes down. 12 goes up, 13 comes down. 13 goes up, 18 comes down. 18 goes up, 25 comes up. 25 comes down. 25 goes up, 27 comes down. 27 goes up with 9, it gives 36. 36 goes up and 44 will be final result. So your S is added continuously with this particular array. Right? So first in a one-dimensional array program, read the length, then read the numbers, and then find the sum using this particular processing value. Let me show you the program of this particular task. So I have this particular program, a sample code written for you with the basic declaration of arrays. So as usual, first include the header files for our operation. Int a of 50 nis, where a of 50 is an array, n is the length, I is an index variable, and s equal to 0 is for sum operations. Right? Okay. First read the length. How many numbers? When I say how many numbers, you have to read this particular n value. Then enter the numbers. So I'll say for I equals 0, I less than equals to n minus 1, I plus plus. You can say less than n or less than equal to n minus 1. Scanf percentage d comma ampersand of AFI. So you'll find that I have read the length and then these read numbers. Once the number have been read, set s equals 0 and keep on adding every element of the array s equal to s plus AFI. So if I consider n as say 3 values, your array will have a task of reading 3 values, say 11, 2, 9. Set s equals to what? Initially 0. 0 is added with 11, comes back as 12. 12 is added with 2, comes back as 24. 24 is added with 9, comes back as what? 33. 24 plus 9 is 33. And finally, once you quit this particular for loop, your s stores the value as sum. Display this particular s as 33 for a given 3 numbers. Right? A simple code to do analysis on this particular example where a was declared as an array, then read the length, then read the number, and then do the manipulation as per the requirement. Right? Go through the entire stuff one more time before you proceed with further programs. Thank you.